Let's draw this Lewis structure. Some compound substances are formed when the electrons of its atoms pair up their magnetic fields. This is called covalent bonding, which we can represent with a symbol called a Lewis structure. Line segments like this one represent the covalent bond, and the dots represent the unbonded electrons around each atom. Now, the two electrons in this covalent bond are now mutually owned by these two atoms. The electron on the left is co-owned by bromine, which makes bromine have 1, 2, 3, 4, 5, 6, 7, 8 total electrons around it. The electron on the left is also co-owned by iodine, which makes iodine have 1, 2, 3, 4, 5, 6, 7, 8 total electrons around it. Having 8 electrons on each atom is no coincidence. Most atoms want to have 8 electrons around them to be stable. When I draw Lewis structures, I account for the electrons by doing this. First, we solve for the total number of needed electrons by all the atoms. Phosphorus needs 8 electrons and there's only 1 of it. Plus chlorine also needs 8 electrons and then there's 3 of them. In total, this structure needs 32 electrons. Then we count the number of available electrons based on the number of valence electrons that each atom has. Phosphorus has 5 valence electrons and each chlorine atom has 7 valence electrons. The total number of available electrons is 26. To get the number of electrons that must be shared, we subtract N and A, which gives us 6. To get the number of bonds, we divide S by 2, which gives us 3 bonds. Then lastly, to get the number of unbonded electrons, we subtract S from A, which gives us 20 electrons. Now, we draw the Lewis structure with 3 bonds. Chlorine atoms currently have 2 electrons because of their bonds. To complete the 8 electron requirement, we take out 6 electrons from our pool over here. We do the same for the other 2 chlorine atoms. Phosphorus currently has 6 electrons because of its bonds. It needs 2 electrons to be stable, and look at that, we have 2 electrons left in our pool. Book your free demo session now.